Hey friends, how's it going? What I want to do is just kind of run through these notes for you. You have access to this in OneNote. You can take it, you can print it out, do it on a separate sheet on the side, piece of paper, or what you could do is you could just kind of take notes on a separate sheet of paper. But what you need to do in order to get credit for this activity is to take it and upload it into OneNote to get credit. So whether you ink on the screen or whether you ink on a piece of paper, it still needs to get turned into OneNote on this page so that you get credit for it. When I refer to this page, I'm actually referring to the page that's under your name in your section group down below, not the one in the content library. So like Alexander, if you click on here, there'll be a page in there that'll be blank that you'll need to submit it to. The video will also be located in that under that section as well. So, but without further ado, let me just kind of walk through these notes with you. Please go ahead and record those notes on the side as you see them transpire on the screen, and we'll go from there. So here we go. We're going to start by talking about solving equations. If you scroll down on here, you can kind of see some equations that we're going to turn around and solve. So I'm going to walk through a little reminder with you on how to do that. And that'll be our first day's activity. So by the end of this, you should be able to solve these one-step equations and two-step equations that involve some fractions here and there and maybe a little bit of an application there as well. So, but to do that, we need to remind ourselves about the order of operations, or what type of operations could be included in an equation, and how to reverse those and undo them to solve for the particular variable that we're asking for. Okay, so the opposite of subtraction is addition. Opposite of addition is subtraction. Opposite of multiplication is division. And I'm going to put an ish on that, and I'll explain that in a second. The opposite of division is multiplication. I'm going to add an ish to that as well, because there's a whole divide by zero thing that gets everything all messed up. So it's mostly the opposite, but there's a little ish with that whole divide by zero that you can't do. Okay, so essentially what we wind up doing when we're solving equations, we're doing the inverse order of operations. If you remember, the order of operations goes, you do parentheses, you do exponents, so grouping symbols, parentheses, exponents, you do multiplication or division, whichever one comes first, left to right, or adding, yeah, multiplication, division, whichever comes first, left to right, and then adding and subtracting, whichever comes first, left to right. So, but we're going to reverse those because we're trying to dig out the value of this variable. So when we do this, we want to kind of look at the right-hand side of that equation, the one that has the unknown, and we want to turn around, we want to dig that out. We want to get that free so we know what that value could be. In order to do that, we try to simplify as much as we can to start, and then we start undoing some things. So in this, we've got to turn around and simplify this. This minus minus is actually going to become a plus 4. And now we're going to undo we're going to undo the operations that are being done to the variable we're solving for. So we're solving for the variable n, and we want to undo what's being done to that. On the right-hand side, currently what's being done is adding 4. That's the operation that's being attached to the n. So to get rid of the adding 4, we're going to reverse that. Opposite of adding is subtracting, so we're going to turn around and subtract 4. And we do that to both sides to keep it balanced, if you remember from before. And we get negative 8 minus 4 will be negative 12, and that's going to be our solution for our value for n. What that means is that if you turn around and you drop that in for n into the equation, and you simplify that right-hand side, you're going to get negative 12 plus 4, which is going to be negative 8 equals negative 8, which makes a true statement. So then we know that that's actually the correct variable. So if we go ahead and look at number 2, we have 2/5 equals a plus negative 1/5. Again, what's happening to the a on the right? Well, we're adding a negative 1/5. We can simplify that if we want, minus 1/5. We can turn around. Now we can see that it's actually just subtracting 1/5. In order to undo that, we would add 1/5 to both sides, and we would get 2/5 plus 1/5 is going to be 3/5, and that's what we'll get for A. Okay, keep going. We have number 3 here. What's happening to P? Well, we have something added to it, so we're going to do the opposite sign to it to reverse it. So we're going to subtract it from both sides. And off to the side, I'm going to do negative 5/4 minus 3/2. In order to subtract them by hand, we need a common denominator. So instead of minus 3/2, we're going to have to get a common denominator of 4. So we're going to multiply top and bottom by 2, 6/4. And we think negative 5 minus 6 would be negative 11. So we would get negative 11/4 on that. Now, you could have done that in a calculator if you feel like it. That's totally cool as well. I just did by hand because it was right here. Okay. If we look at number 4, we have negative 3 times x. We want to reverse that. So if we divide by negative 3, we'll turn around and we're doing the opposite operation. And 2 divided by negative 3 as a fraction, we're going to leave it as a fraction. It's negative 2/3. Number 5 here, turn around. This is actually x divided by 5. So we're going to reverse that by multiplying both sides by 5. So we get x equals negative 15. Because negative 3 times 5 is negative 15. Here we go, number 6. This is, you can kind of see this 2 ways. You can see 1/2 times x if you want. Or you could actually see it x over 2 equals negative 20. Either one actually works. But if we have it times, we would divide by 1/2. Now you can turn around and type that in your calculator. But if you see that this is actually x divided by 2, if you can see that mathematically based off of how it's written, you can just multiply both sides by 2 to get rid of it because it's the inverse operation. And we would get x equals negative 40 for that. Again, if you question whether that's correct or not, you can go ahead and check your work by substituting negative 40 in for x and see if that equals the other side of the equation. 1/2 times negative 40 is going to be negative 20, and we will end up getting the same spot. Okay. Go down to this. Now, when we have two-step equations, we can turn around. We can look at it. We want to, again, inverse order of operations if we can, or you want to see like what's the weakest link that's bonded to the variable. So like if I look at number 1, for instance, I have negative 3 minus 7. I know that x is negative 3x minus 7. I know that the x is there. I see that there's 2 operations here. There's a times and a subtract. And I want to think what is like the weaker out of those 2 to get rid of first, which would be the minus 7. It's kind of a quote unquote, obviously that's in quotes, but a weaker bond. So I would turn around and I would add 7 to both sides to get rid of that. Negative 3x equals 9. And we divide by negative 3 because we have negative 3 times x. We get x is negative 3. So 9 divided by negative 3 is going to be negative 3 as well. Over here with number 2, look at how to get rid of it, which bond on the variable is weaker. Is it times or is it minus? Well, it's minus. Again, it's the inverse operations, order of operations as well. The very last thing we would do with order of operations would be add and subtract. So we're going to get rid of that first if we can. So we're going to add 5 to both sides. We get negative 5 equals 1/2 x. When we're at that spot, we have that 1/2 x again. You can view it as 1/2 times x if you want, or if you see it as really it's divided by 2 as well, you turn around and just get rid of it by multiplying both sides by 2. And you get negative 10 equals x. And two last questions. So here we have another situation. This one actually has a grouping symbol. It's kind of hard to see. We have the grouping symbol right here. We have the grouping symbol. Here we have this question, and we have the grouping symbol of divide by 12. This is this whole group, this whole quantity, x plus 9 divided by 12. So what's interesting when we're looking at this, we kind of have to dig out that k. So we look at like what's trapping it on that left side. So there's that plus 9, and then there's also the divide by 12. But the tricky thing here is that the plus 9 is like trapped inside of a divide by 12, if that makes sense. So the weakest thing, the thing on the outside, the easiest to get rid of, the quickest to get rid of, the least complicated thing is actually this divide by 12. Because that plus 9 isn't just a plus 9 in there. It's plus 9 divided by 12 because it's grouped. So we want to get rid of this 12 on the denominator first. So we'd wind up getting negative 24 on the right-hand side, and then we would minus 9 from both sides. K is negative 33 in that case. So because negative 4 minus 9 is negative 33. Now, if that was a little confusing on that one, like how to actually do it, how to see it, how to view it, we'll talk about it when you're in class. Please make sure to ask about that one in particular if you have concerns or questions on that. Let's turn around and go to the last question. All right, Mr. Thill has solved the problem 6p minus 12 equals 72 and says that p equals 14. How can you check to see if Mr. Thill is correct? We'll address that when you guys are back in class tomorrow, because I want to hear your explanation, your answers in person. So hopefully think about that and ponder that, ruminate on that, and we'll see you tomorrow. Peace.